So this is part 6 of my Kyosho Rampage Pro E electric conversion build series, and I know it's been several months since I posted the last build, or the last part of this build series. I've been rather busy with the kid and work and everything as usual, but I've tried to make some time, putting in very late nights trying to finish this up and get it all together. So basically, the build is complete now. All the electronics are installed. I have the wheels and tires all set, and all that's really left is to just get the steering and camber alignment and the ride height adjustment, all the basic alignments, if you will, and setups, and then it's ready to run. But functionally speaking, it's complete. So there are a few things, a few details here to go over since last time. I think where I left off last time was with how to do the battery mounting, and I mentioned that I was going to mount a shorty pack laterally across the chassis toward the back of the chassis, which is what I did here. And this is just a RC10 battery cup that you would get for like a vintage RC10. Team Associated still makes these, and I just took that and I taped it to this side of the chassis. And when you actually put the shorty pack in, there's some clearance between the shorty pack and this top plate here that I fabricated. So rather than get like a T plate to hold the battery down, I instead just taped some foam to the bottom of this upper plate here. And this actually holds the battery in nice and snug when you put it in and sort of push it through under the foam to this side. So the end of the battery sits at the right edge of the chassis here. And then to fill the remaining space, I just have a little foam spacer that I put in here. You'll notice that I also actually cut a little bit of material out of the side of this battery cup here. And that's because I actually had to do that to be able to get the battery in at any angle that won't end up causing the battery to bind, if you will, against this upper deck here. So you have to cut some material out of here to actually be able to slot the battery in. You put it in, and then you just use this little plastic piece here to hold it down, and then foam spacer to pick up the slack. You actually want to cut some piece of the end of the foam spacer here so it doesn't take the full width of the battery cup. The reason for that is this is going to fit in rather snug between the battery and the battery cup, and then if you have to take the battery out again, you take this little piece off, but then you have to take this foam back out, otherwise you can't pull the battery out. It's a really tight fit in here, and you can't pull it out if it's very tight this way and very tight this way. So you actually need a gap in there to be able to sort of get your finger in there and pull the foam spacer out. So make sure you do that. Let's see. For the speed control, I'm using the Turnigy 60 amp stock speed control. So this does not have a dynamic timing option like their 80 amp and 120 amp speed controls. But since I'm running a 17.5 motor in this, it should be fine. This is the exact speed control I used to run in my B5M factory light for the last few races that I ran that car. And this is a really, really good speed control for stock racing, and it's only about $30 or so. It's incredibly cheap, and I've never had any issue with it. Now, considering that the Vonats, the Vintage Off-Road Nationals, does allow dynamic timing, or boost, if you want to call it that, for speed controls, I had considered putting the Turnigy 120 amp speed control in here. It's a little bit bigger. I just didn't have one lying around. I figured this would be more than good enough, especially since with stock buggies, with a good motor like a D4, 17.5 or something like that, you can be about as fast as a mod buggy for a small to medium-sized track. They're pretty close in time, so I don't really feel like I need any dynamic timing advantage with stock buggies for the most part. So this should be plenty fast. Transponder is over here on the actual chassis, mounted as close as possible to the front, without getting in front of the servo or into the steering, linkage area. So that's what transponder is. Receiver is right here. It sits just to the side of the battery. So the battery comes in like this. Receiver sits on the side. So everything fits pretty nice, and there's a little bit of space here. Looking top down, if I wanted to fit a fatter speed control in there, I probably could. I would just have to maybe move the receiver to a different location, maybe like to the top of this plate here. But then the body, it sort of comes down. This piece here comes down onto the upper deck here. So any place that I would mount this receiver, if not on the side here, would actually have to be along the center line. So I might actually have to mount on top of the battery if I were to run a fatter speed control. But most speed controls, modern speed controls, aren't that big, so you shouldn't have that kind of a problem. So electronics mounting was, no big deal here. What else do I want to mention? The wheels. Okay, so I did spend quite a lot of time trying to figure out if I could run modern hex rims on the Pro X. Now, the Pro X rear wheels, which is this guy here, these are actually hex rear wheels, 2.2 inch with a 12 millimeter hex, just like a B5 or an RB6 hex wheel. The difference is that these wheels have a very, very deep offset. So this side is the inside of the wheel. It mounts this way. Okay, so the hex is almost on the outside of the wheel over here. Okay, and the modern B5 and B6 and RB6 rims also have kind of a deep offset, but it's not exactly the same depth. So you have to use a different wheel hex to account for that. So this is a 6 millimeter wheel hex, okay? And the Pro X wheel hex, I just have it for comparison right here, it's a little bit narrower. If I sort of look top down here, that's maybe about 4 millimeters or so. And that extra 2 millimeters makes the difference. That brings the rear width right about to where it's supposed to be. I didn't measure it exactly, but I just sort of eyeballed it relative to where the front wheels are and just tried to make sure they're about equal. So this 6 millimeter wheel hex does the trick. You just have to make sure to get the right kind of 6 millimeter wheel hex. I started with a Team Associated 6 millimeter wheel hex, but the problem there is that the Associated drive pins, the pins that go into the wheel hex itself, like on this side, those are actually narrower than the Kyosho drive pins. So if you want to put something on a Kyosho axle here, especially like a vintage Kyosho axle, you have to use wheel hexes sized for Tamiya or axial chassis. So this particular unit here is made by Integy, and they make wheel hexes of a whole variety of sizes for Tamiya and axial chassis. They also fit perfectly on Kyosho chassis with either the vintage wheel axles or the modern wheel axles. They actually use about the same pin size. So do that, and you can run RB6 rims at the back, no problem. I did think about trying to do a hex conversion to the front here, and you could say the simple solution to this would be to just take an RB6 steering block and caster block and just find a way to mount it onto the arm. But then that wouldn't make it, that wouldn't be in the spirit of keeping this a vintage car, right? I want to keep the geometry, the intended steering and suspension geometry that Kyosho designed into this car with these particular caster blocks and spindle carriers. Because you can see here, for example, like this spindle carrier tilts down like this, and the caster block tilts in like this, and they did this for geometric reasons. So I don't want to disturb that. So that means finding a way to do a hex conversion on this existing wheel axle here, because this axle, I did look at like Team CRP wheel axles. Team CRP does make some conversion wheel axles that will allow you to take like Kyosho wheel axle of some other model, maybe the Triumph or something, and run a different diameter wheel axle on it so that you can use like 5 by 10 millimeter bearings instead of the 4 by 8s or whatever they use on that particular wheel axle. So that gives you more cross compatibility between different cars you have. But they don't have a corresponding wheel axle for the Pro X and the Rampage Pro series because the holes that this pin goes through are not symmetric top to bottom, right? The hole on the end of this wheel axle at the top is really out toward the end, and then it comes in a little bit like this. So the holes are at an angle. And all of the conversion wheel axles they make, the holes are perfectly vertical through the wheel axle, so they wouldn't actually fit on this. So really you're confined to having to make a hex conversion work on this wheel axle. And so far I have not found a solution. The only things I have found that I've tried to date are the GPM hex conversion. So this is basically a wheel hex with a 5 by 8 millimeter bearing on either side of the wheel hex. Okay, so this would actually work on a Tamiya wheel axle quite nicely, because Tamiya tends to use 5 millimeter bearings for the wheels. But this particular Kyosho model, the Pro X, Pro XRT, the Outlaw Rampage Pro, the Rampage Pro like this, uses a 6 millimeter inner diameter on the bearing. And so I needed to find something like this with a 6 millimeter inner diameter bearing. Now I did try to look for buying a 6 by 8 bearing and putting it in these particular wheel hexes, but nobody makes a 6 by 8 wheel bearing. The bearings would be super tiny, and the inner and outer diameter differences would be too small to make a good bearing, which is, I guess, is why you can't really find them. So this solution doesn't really work, because the outer diameter of the bearing that goes in here is 8 millimeter. So then I looked around and I found that RPM, or supposedly it's RPM, made these hex wheel conversions for the Tamiya Blackfoot. And it has, I think, like a 5 by 11 millimeter bearing that goes in on this side. And I think it's just I think you put both bearings in the back side here. And then this opening here, even though it's an opening, you don't actually put a bearing in on this side. This opening is like about a 9.5 millimeter opening. So you can't fit a 10 millimeter bearing in there. You can't fit a 9 millimeter bearing in there. So if you were to use something like this, you could get a 6 by 11 bearing and slot it in from the back here, and that would actually fit on this wheel axle. But the problem is this particular unit is very deep. It's actually deeper than this axle is wide. So you wouldn't actually be able to mount this and then mount the wheel and tighten everything down. The wheel would be pushed too far out. So you need to find a way of basically cutting off most of this material and mounting a bearing in here in the front side, so you can push that hex in, so that you can have something, with the right offset. So when you use a modern B5 or B6 hex front wheel, you get the right offset. So I spent some money trying to find different solutions here, and I couldn't find anything that really works for this axle. So I just decided to use the Pro X front wheels that I have, because I have several of them. And so I just have to accept that whatever tires I mount on those wheels will only be used on this car. So that kind of sucks, but at the very least, I have some cross compatibility with the rear wheels between this and my RB6 and my B5s and so forth. Yeah, so I think that's it. I don't think there's anything else really to discuss. I did go to Home Depot earlier today, and I picked up some 4 millimeter spacers here. The idea being that if I needed to reduce the rear anti-squat, I could do so by putting some shims between this rear inner hinge pin block and the chassis. And the screws that screw through these two holes here are 4 millimeter screws. Okay, so you just get some 4 millimeter spacers like these guys from Home Depot. They're super cheap, and you could just do one by one. You could shim this a bit to move this block up, and that will flatten the angle of this suspension arm relative to the chassis to reduce anti-squat if you happen to need to do that for your particular track. So I just wanted to make sure I had that as a tuning option. And yeah, I think that's it. So I hope this has been informative. I know this particular build I've had in mind for about 2 years, and I've been sort of working on it slowly over time. So I'm happy that I have it done. And now that this is complete and I sort of figured out all the little kinks, I'm going to try to do the same thing on an Outlaw Rampage Pro, which is basically the truck version of this chassis. So that's what all these pieces here are for. That's why I have a big mess here on this desk. I'm trying to work on an Outlaw Rampage Pro E project, and also up there I have a Pro XRT that needs to be rebuilt as well. So some of these parts are for that as well. So I hope you found this informative, and until next time, thanks for watching.